that we did on the ventilation systems. There'll still be people probably coming on. We have Kaylee Rainier-Brown, who some of you remember worked for OBES Risk, now works for Jensen Hughes in Halifax. She will be doing a summary of the report that was already presented. Did we present the report at all or send it out? Can't remember. Probably not.
Yeah, it was dated August 19th, so I'm not sure if it was shared internally.
Okay. So we'll do a quick summary of the bow tie and what happened and next steps and all that good stuff. And so welcome, Kaylee. I'll hand it over to you.
Oh, thanks a lot, Bill, Tammy, for setting this up. Good afternoon, everyone. Really nice to be meeting with you guys today. So like Bill said, this is just going to be a brief summary of the bow tie analysis of the ventilation systems containing combustible dust that was conducted in about June or so. Like I said, the report was shared with the council mid-August. So certainly, if you haven't received your own copy of that yet, touch base with Bill and Tammy. This is the report that we're going to be referring to throughout the course of this webinar. So we'll just kick off today's webinar with an introduction into really the scope, motivation, and objectives of the work that was completed. We will provide a summary of the bow tie analysis methodology for some of you who might not be familiar with it, as well as the workshop that was conducted. I'll then provide an overview of the bow tie analysis, specifically with respect to the results that and the outcomes of the bow tie analysis, specifically around the evaluation around ignition sources and critical controls, and some recommendations for safeguards. The next thing that we'll cover in today's webinar will be really a summary of the opportunities for improvement or gaps that were identified, as well as available resources. And then we'll close out the webinar with a few closing remarks and, like Bill mentioned, next steps. So the scope of the work and of the bow tie analysis was namely ignition of combustible wood dust in ventilation systems in wood products manufacturing. So it was primarily sawmills, but attendees were there from wood pellet plants as well. So when we refer to the ventilation systems, we are talking about collection points, the ducts, bag houses or cyclones, fans and blowers for various wood processing and handling equipment. And that includes planers, saws, side heads, bins and silos, and we also included mobile equipment as well. We did assume that all dust is deflagrable. So as per the NFPA 664 definition, deflagrable wood dust is defined as wood particulate that will propagate a deflagration flame front when suspended in air or process-specific oxidizing medium in adequate concentration, therefore presenting a deflagration hazard. The work also included, like I said, identification of critical controls, as well as opportunities for improvement in order for operations to help develop corrective action plans. What was the motivation for this project and for this work? So it's the fact that ventilation and dust collection systems in facilities are a major concern. Dust collectors are one of the highest hazard areas in facilities that are handling combustible dust. And this is really due to their inherent nature and design. So we have suspended dust within enclosures. They're interconnected within the process and throughout the facility. And there's also obviously a lot of opportunity for ignition sources like static electricity and things from mechanical failure as well. Ignitions from mechanical failure. Deflagrations, because of that interconnected nature, they can easily propagate throughout ventilation systems if there is a lack of effective ignition source control and explosion protection, like deflagration isolation. So bow tie analysis allows us to really systematically evaluate and assess how combustible dust ignition can occur and allow us to further evaluate existing risk controls that are in place or that could be in place in order to ultimately improve risk management. The objectives of the bow tie analysis workshop, like I mentioned, were really to improve and enhance that understanding of how ignitions and deflagrations of wood dust that can take place in ventilation systems can arise. The bow tie analysis workshops also lend themselves very well to peer-to-peer learning in this workshop format, where we have a broad range of stakeholders from many different operations and backgrounds, allowing everyone to learn from each other, share their own perspectives and experiences. And of course, throughout those types of discussions, that also allows everyone to learn about other practices that other facilities have incorporated. And excuse me, throughout the discussion and systematic analysis, it allows you to identify additional safety measures that should be implemented by identifying those gaps. So again, just a brief overview of bow tie analysis, if this is a new concept or tool for any of you. So we have the hazard here in the black and yellow box. That is the scenario or the condition that has the potential to cause harm. So in this case, our hazard was combustible wood dust in a ventilation system. The top event is that kind of central occurring event that you ultimately want to prevent. In this case, we chose a top event of ignition. Threats are on the left-hand side, and those are the scenarios or situations that could lead to the top event. So this really focuses on your ignition sources. So things like mechanical failure, self-heating, propagation from upstream or downstream of a flame front or of a deflagration, hot work, mobile equipment, hot surfaces, those types of issues that can arise and lead to deflagrations or ignitions on mobile equipment. And in wood products manufacturing facilities, obviously, more generally. On the right-hand side, we have consequences here in the red boxes. So if that top event or an ignition were to occur, what would be the potential outcomes? So if you had an ignition, say, in a dust collector, the potential consequence would be a deflagration, asset damage, potential harm to personnel, business interruption. Next, we examine our barriers. So those are the controls that are in place to either prevent or mitigate a top event. So on the prevention barrier front, we have things like preventative maintenance, hot work program activities, online condition monitoring, spark detect deluge. On the mitigation barrier side, we have things like deflagration isolation controls, whether it be chemical isolation or mechanical valves. We have emergency response plans. Even housekeeping can actually be a barrier on either side, because housekeeping as a prevention barrier would remove fuel from, which would help prevent an ignition in the first place if you don't have fuel. Housekeeping also serves a purpose on the right-hand side as a mitigation barrier, so that if you have an ignition, the removal of that fugitive dust would reduce the severity or likelihood of a secondary explosion. The last important element of bow tie analysis to highlight is your degradation factors and controls. So unfortunately, barriers are not 100% effective. They can be defeated. So we capture those in your degradation factors. Those can be things like, malfunctions, SOPs not being followed, things of that nature. So then we need our degradation controls. So those are the additional measures that we need to implement in order to make sure that our barriers are more reliable. Those can be measures like auditing, training, redundant systems, so on and so forth. So like I said, the part of this work did include the identification of critical controls, and that really comes down to your prevention barriers and your mitigation barriers. So critical controls may be deemed critical if, say, a control is in place for a threat that has a very high probability of leading to a top event. So we know mechanical failures have a high likelihood of leading to an ignition. So things around preventative maintenance, in my experience, it seems that a lot of operations are deeming preventative maintenance as critical. A control is in place for a consequence that has a very severe or high risk. So something like a deflagration isolation would frequently fit this kind of criteria as well. If a pathway has very few controls, so if we look at our prevention barriers here, if, say, your threat is a very high likelihood of occurring, however, you only have one barrier, an operation could deem that as critical. So there's a couple of other criteria here as well, and these were kind of the basis for the discussions for identifying critical controls. And it's important to note as well that what one operation may deem as a critical control might not be the same as others, kind of based on whether it's risk tolerance, risk profile, experience. That's kind of where that expert judgment comes into play. And I think that also your critical controls can probably vary as your operation evolves and matures. So let's get into the bow tie analysis results and summaries. So again, when it comes down to ignition sources and those threats that were identified in the bow tie analysis, I split it up between the different operating conditions, so routine, non-routine, and emergency. So kind of within this routine category, we can have ignition sources from tramp metal, wood processing equipment, obviously accumulations of dust in pipes or duct dead legs, bins, other areas. So when you have these, notable dust accumulations, then, an ignition source is a higher threat. Ignition source from planar jointing, material smoldering on hot surfaces, ignition sources from adjacent processes like nearby energy systems, static electricity. We also identified an interesting threat, which was the ignition of accumulated material in ventilation systems that are not actually intended for transferring wood dust, but inherently intake wood dust. So an example of this could be ventilation for weld fumes. So this was an area of interest that we discussed and evaluated. Another one was ignition source from makeup air and heat exchangers that propagates into process ventilation, an ignition source from personnel smoking, electrical failure or arcing, and an ignition source from friction on sanders. Non-routine involved ignition source from hot work, and we also had an interesting discussion around the use of burnt wood. So just across the change that's happening in some operations using different species and a fiber mix, that does present other new risks that the team kind of determined need to be evaluated further. And lastly, emergency or upset conditions. So some different ways that ignition can occur can include ignition source from mechanical failure, again, a friction fire on other wood processing equipment, an ignition of hydraulic fluid due to a line failure, an ignition source propagation to a chip or surge bin, and this could be due to hot work, again, mechanical failure, a fire, and even when debris or material has built up around an auger or a belt. Other threats include an ignition source from burning material from an abort gate during upset conditions. And that again kind of is looking at if there's an upset condition at an adjacent site or process. Namely, in this case, a sawmill being nearby a pellet plant. An ignition source from a fire on a mobile equipment or sparks from a bucket, again, kind of making its way into the ventilation system that method or that way. And again, this was looking at even further adjacent areas. So fugitive embers or hot particles from, situations like forest fires, fires again at adjacent facilities, or an ember on a conveyor or process equipment. So several preventative barriers were identified as critical controls by this workshop team. So this included routine lubrication, preventative maintenance program, the equipment setup, thermal monitoring, and bonding and grounding. And let's look at some cutout diagrams now. So these are some excerpts of the bow tie analysis that was developed. So you can see ones that were deemed highly critical, and you can also see some that were marked as opportunity for improvement. And these are summarized later. So for this example, the threat was ignition source propagation to a chip or surge bin, and this could be due to any of the reasons listed there. So in this respect, the preventative maintenance or PM strategy to prevent mechanical failures. In this case, was a hammer mill failure, was marked as critical. So again, like I mentioned, preventative maintenance strategy. And here were some opportunities for improvement that were identified. So consider if the chip bins in a given operation actually need to be enclosed. So consider an alternate design. And that kind of falls within that inherently safer design, risk reduction approach where, can an alternate design be used to actually reduce a hazard. Another opportunity for improvement was consider the belt or conveyor design to prevent ignition source propagation. Again, kind of along that inherently safer design mindset. Considering deluge on bins, that's kind of an engineering approach. And lastly, another opportunity for improvement, or OFI, was considering the addition of a multi-gas detector to identify smolders within, chip or large storage bins. And this would help prevent ignition sources from entering the ventilation system. Here's another excerpt. So again, this is what I mentioned around systems like weld fume hoods intaking wood dust that are not actually meant for wood dust. So here are some opportunities. So opportunities for improvement that were documented. So needing to review and update the consideration of other ventilation systems to assess the risk associated with them. And this is another part of this is raising awareness around potential issues of hygiene or potential plugging. Another opportunity was establishing a PM program, including routine inspections. Visual camera monitoring, as well as a housekeeping program, were also other potential barriers that were identified by the workshop team. On the right-hand side, so looking at the consequences. So in this case, we have the ignition that could lead to a fire or deflagration in a cyclone, baghouse, silo, conduit, machine centers with pickup points, and this is due to the propagation of the ignition. So we had a number that were marked as critical. We have spark detect deluge, the building sprinkler system, dampers, abort gates, fire dump, deflagration isolation, whether it be in the form of chemical, a gate valve or a flap valve, and lastly, the emergency response plan, including routine drills. And I think the other part to highlight here is this opportunity for improvement. So even with an emergency response plan, it's highly critical. And an important aspect of that was raised was ensuring that all critical equipment is available and that the ERP is actually practical. So considering the location of manual stops and controls to make sure that people can actually reach them if they do require any manual input. And I'll highlight another consequence, which was a secondary explosion in a confined area or room due to accumulations on horizontal surfaces. And another OFI, again, that opportunity for improvement was that emergency response drill. So like I said, numerous mitigative barriers were deemed as critical controls as well that we just saw. So spark detection and deluge, building sprinkler system, and these engineered controls like dampers, abort gates, and deflagration isolation, as well as the emergency response plan. So how do we start looking at the reliability of critical controls? So ultimately, assessing critical controls for their degradation factors helps improve their effectiveness. So this report did outline the degradation factors that were identified both in that workshop and through previously completed work between WPAC, the BC Forest Safety Council, and the research that we've done. So an example of one that we actually worked in this current workshop was the equipment setup. So planer saws or other wood processing equipment. And remember that was in order to prevent an ignition source inherent to that equipment. So degradation factors included out-of-date documentation like machine manuals, calibration, standard operating procedures, personnel not being trained adequately, and failure of management of change or MOC to adequately address temporary changes or deviations. So some suggested corrective actions include formalizing an MOC program following best practices and defining procedures and parameters for restarting and resetting processes. So ultimately, after identifying your critical controls, or looking at the controls that you have in place, consider how can my control fail and what do I need to have in place in order to prevent this? Now we'll summarize some opportunities for improvement. So this report, some of the work that I did afterwards was looking at the opportunities for improvement that were identified and categorizing them with respect to management system elements. The management system that I used for this was the CSA Z767 Process Safety Management Framework, but really there would be a lot of overlap with generally other safety management systems that you might be more familiar with. So the excerpt of the opportunities for improvement that I'll show here will be defining an installation and operational procedure and training. And this was for the threat of an ignition source for mechanical failure. So defining these procedures and conducting training fall within the management system element of training and competency and process safety information and documentation. For safety culture training and education. And this was around the degradation factor of personnel or staff don't have the complete don't complete the installation correctly because of any reason, whether it be complacency or real or perceived production pressures. So that falls within process safety culture, leadership accountability, and conduct of operations and operational discipline. I know conduct of operations is a fairly new concept to this kind of sector. So just a very high level definition is that conduct of operations ensures that operational and management tasks are completed consistently to achieve defined safety goals. So it's basically, an operational discipline is completing the right thing every time, if you will. And lastly, online predictive monitoring and trending program that would be for temperature and vibration. And this was to address the threat of an ignition source for mechanical failure. So in terms of a management system element, that falls within integrity management. So you can review the report to see that complete categorization. And that might just help you identify some gaps within your own management system and reflect on potential next steps for yourself. And as always, when it comes to identifying opportunities for improvement, I encourage, and we should, it's best practice to consider the hierarchy of controls, the preferred order of risk reduction measures. So this is one version of the hierarchy of controls with inherently safer design at the top, followed by passive engineered, active engineered, and administrative controls. Other hierarchy of controls that you would be familiar with as well would follow elimination, substitution, engineering, procedural, and PPE. But inherently safer design includes elimination and substitution. It just also includes simplification and moderation. So you can read some of the publications that we've done with the council, with WPAC on inherently safer design. But of course, as you are looking at next steps after this workshop, when you're reviewing, or after this webinar, reviewing the report and formulating action plans, just remember to try to rely less on administrative and procedural controls and try to move higher up that hierarchy, lean more heavily on engineered controls. And of course, if you can actually eliminate the hazards through an alternate design, like I said, if you can incorporate inherently safer design, that'll be the most effective. We do have that Bill and I developed last year, an inherently safer design guide sheet. So it's just a simple 2-pager that has a sample of ISD examples and some checklist questions. So again, to kind of help formulate those next steps, you can go through some of those checklist questions to help develop solutions for inherently safer design that are more applicable to your specific operation and your specific hazards. So we're getting now to the recommendations next steps. So it is recommended that you review your management system to identify gaps and formulate action plans. So in our recent research that we published, we developed 6 self-assessment worksheets. Again, these are based around the CSA Z767 Process Safety Management Standard. So those are focused on accountability, management of change, safety culture, investigation, risk management framework, and key performance indicators. And in 2025, we will have these upcoming self-assessment worksheets available as well. So the remaining 12 will be available. So you can see when it comes to, emergency management planning, process and equipment integrity, we'll start to be able to conduct more gap assessments on management systems in order to, strengthen those controls and, more effectively identify potential hazards. And of course, track improvement. We talk about key performance indicators in this available self-assessment worksheet that would really help you start to, trend near misses, trend, things like ignitions or smolders, develop those action plans, and then actually monitor improvements in your processes. So I've mentioned the self-assessment worksheets that are available. This is just one example of the management of change one that is on WPAC's website that you can also get from Bill. This one in particular is about 6 pages or so, but you can see, there's an area to establish, do that gap assessment, establish an action owner, and start to formulate that internal structure for yourself to develop some corrective actions. And if you have your management of change program formalized, that's great. This might help you identify some potential ways to strengthen that. And if you don't have a formalized management of change program in place, will be a great place to start. And there are some resources available that we collected through the research that will actually help get you started on your own management of change program. There are additional tools and resources that are available and recommended to address some of these gaps and opportunities for improvement. So the BC Force Safety Council has done a lot of work on critical control management. So there are some resources that are available on how to apply that framework. Bill will also be conducting a validation process of this bow tie analysis with individual operations beginning in at least 2025. So Bill will speak to this after the webinar, but that would really just entail building on the bow tie analysis that we've already completed and customizing it for your own facility. So Bill will speak to that more when we're wrapped up here. We had a couple of very successful, very well-received workshops earlier this month, focusing on the proposed WorkSafe BC combustible dust regulations and critical control management. So we ran it on October 8th and 10th for a full day. It seemed like there was great conversation, great discussions, great questions were had. I think that Bill would like to provide another one in the near future as well, just based on the good demand that we had. So stay tuned for that. As part of that, we did develop a 2-page self-assessment tool to help that you could use to help kind of measure yourself against kind of the new expectations of the WorkSafe BC regulations. So that can be kind of one of the first steps that you can do in terms of preparing for these new regulations that are expected to come into force in 2025. The NFPA standards are online for free with an account set up, so I suggest you review those as well. We talked a lot about the NFPA standards in those in-person workshops, so I recommend you check those out for other recommendations and requirements. One thing that we didn't talk a lot about in the bow tie analysis was the NFPA standards and some other best practices around ventilation systems, so I encourage you to review those. And some other good discussion, like I mentioned, that we had in the workshop was around their new risk profile that some operations may have to contend with if they are processing burnt wood. So also stay tuned, and the council will be conducting some work on that as well. So watch this space. So in closing, The bow tie analysis we conducted helped to really effectively evaluate a lot of the potential sources of combustible dust ignition, as well as existing and potential controls. Critical controls that were identified included preventative maintenance, thermal monitoring, deflagration mitigation, suppression, isolation, and your emergency response plans. Inherently safer design options and the hierarchy of controls should always be assessed when it comes to eliminating and reducing hazards. And a lot of the opportunities for improvement that we identified are linked to your safety management system. So we encourage you to conduct a gap assessment and help improve your systems by updating your programs in order to strengthen them. And I'm happy to take any questions. Over to you, Bill and Tammy.
So Tammy, are we able to unmute everybody?
I can try that, sure. I'll go ahead and do that. They'll have to unmute themselves, but I'll allow them.
Okay, everybody, thank you very much, Kaylee. That was great. Nice summary of the report, which will be going out to everybody if you don't already have it. There's multiple parts to the report that will be going out, the original report. And we have sort of visuals of the bow tie that can go out, PNG files. And so, you know, it's worth a look through. Kaylee also mentioned the validation process. We are set up to come to various operations to validate the ventilation bow tie for your operation. So we export it to Excel. We will come to the site, working with a group of people on your site, and from there we sort of take what you got on your site and the controls that you have, and we reverse engineer it back into a bow tie that we can send to you, so you've got your own bow tie analysis specific for your operation. And this will come in handy for you know, as they implement the new proposed combustible dust regulations, in that you will have something there that, in terms of process dust on your site, you can say, listen, we've got this bow tie that's specific to our operation. Kaylee also mentioned burnt wood. We are sort of in the negotiating phase to redo what many of you might know about or have seen, which was the FP Innovation analysis they did on wood dust in BC back in 2014. And it gives all the various values that you need to size your deflagration isolation equipment, or to give you an idea of how your wood fiber has changed since that time. Because we do believe, and from the research we did with some other industries like the coal industry, we did get some information that said the running of burnt wood could produce significant changes in the characteristics of your wood dust that you should know about, at least as a basic industry level. After we've done the research, if you really feel that there's enough changes at your operation, then it might trigger the need to maybe do a little bit of dust testing in certain areas. So it's probably a short and quick way of identifying what potential risks that you might have on your site, and whether you need to, instead of just assume like you can for the ignitability and deflagrability, you might say, okay, well, we've got enough changes here from what we're seeing that maybe we should do a little bit of dust testing here to make sure that our equipment is going to work as planned if we have a deflagration. So those are some of the initiatives that are coming up. Kaylee mentioned the phase 2 and phase 3 assessments that we produced phase 1 already, and this is was part of research that we did for the integrating process safety management into operations. We have the first set, phase 2 and phase 3. We are basically in negotiations to get those completed in 2025 so that everything will be there and companies can work at their own pace on those. One thing that I will highlight in phase 1 assessments is I really think management of change and investigations probably would be the ones that you might want to start with, because management of change could be the vehicle to help you identify gaps in your systems. If there's been changes and you haven't done a proper management of change, you might not know what you need to be changing to improve your systems. And then investigations is more of a reactive type of process, where when you have events, and hopefully if you have minor events like a near miss or maybe a failure of a control, that you can investigate it and determine what happened so you can improve your system again to a higher level, so that it can help you avoid a catastrophic event in your ventilation systems. So that's some of the stuff we have coming up, and also another critical combustible dust critical control workshop, maybe targeting closer to the Lower Mainland, so we can capture some of the operations on Vancouver Island and in the Lower Mainland. So any questions from anybody on the Kaylee's report or summary? If you're having problems unmuting or putting your question in, you can also put it in the chat. Kaylee, do you have anything else to add?
I think you covered it really, really well, Bill. I think it was, again, a really successful bow tie workshop. And again, I think another one of those workshops on the proposed combustible dust regulations really help kind of put a bow on this kind of work. So I would encourage all of you, if another one, if you weren't able to attend the two that we had earlier this month and another one is hosted, I'd recommend attending. But otherwise, I think that's it from me, Bill. I think you have all the resources at this point that you'll be able to share with people. The 2-pager on the proposed regulations. Tammy, I'll send you these updated slides, since I made just those couple little minor changes, and we'll be able to share the slides with everyone. And I think that's it. I just appreciate you guys having me on today.
Okay, thank you, Kaylee. So if you're interested in doing the validation at your operations for the ventilation bow tie, it can either be done as a company if you have multiple operations, maybe grouping close operations together to do it, or individually. Please let me know so we can get you on the list so we can start doing the planning for 2025. If you see some demand with your operations or employees for the combustible dust critical control workshop for the proposed regulations, please let me know, because if we have enough demand, that's when we'll put that on. And we can do one as early as possibly December. I don't know, Kaylee, whether you want to travel to the coast. Maybe if you're just traveling to Vancouver, it's not so bad.
Yeah,
but
exactly.
I do know there's some operations that we missed out on that might want to participate.
Yeah.
Okay, so thank you very much, everybody. Thank you, Kaylee, and thank you, Tammy, for all the work you did for the workshop or the webinar. Sorry.
Likewise. Okay, thank you.
Okay, goodbye, everybody.
Bye-bye. Bye.